Alright, let's take a look at this geometric sequences and equations. So we've dealt with arithmetic sequences. Remember that arithmetic, it grows with addition or repeated subtraction. Okay. So the geometric, which is what we're dealing with now, that's multiplication and division. Though we really think of it just in terms of multiplication, right? Because dividing by 3, that's the same as timesing by 1/3. And it's mainly because of those explicit equations that we do that. Okay, so again, just like with arithmetic, it all comes down to where does it start, how does it grow. Okay, so remember, this is our first term, second term, third term, fourth term. We want to go back to 0 term. So how do I get from 4 to 12 with multiplication? Well, we'd be timesing by 3, wouldn't we? Each time. 12 to 36, times them by 3. So if I go backwards, what times 3 would equal 4? Or in other words, what's 4 divided by 3? That's 4/3. So I just leave it as 4/3. So my starting number, 4/3. My growth, times 3. So recursive, just like with arithmetic, it starts the same way. A sub n equals a sub n minus 1. Then what's my constant ratio, my growth? It's times 3. What's my 0 term, my beginning? It's 4/3. There's my recursive. Explicit, we go a sub n equals, and then where do we start? 4/3. What are we doing to 4/3? We're timesing by 3. Then, because of that growth, we need to put the variable with the growth. And here's where people seem to really make their mistakes when it comes to explicit equations. And you have to think of this. So, in arithmetic, we're always adding the same number each time, right? And the way we shortcut that is through multiplication. 5 3s, 3 times 5. Okay, so it's like to show that repeated multiplication, we take a step up, or that repeated addition, we take a step up to multiplication. Okay, so similarly, when we're just multiplying, okay, we take a step up from repeated multiplication and we do the power. So for geometric, your variable is always going to be to the nth power. Okay. Now, sometimes you get some weird numbers like 4/3. You may not have liked that as much. So let's say instead you wanted to do the first term, which was an easier number, was 4. Okay, you can do that in the recursive. It's easy. You just go a sub 1 equals 4. Well, how do you do it here in the explicit? Well, we would have started with 4. The problem is 4 is one term off of my 0. So to get it back to 0, you'd have to go n minus 1. Okay, so you can do it that way, but I'm going to always do it the other way, just because that's the way I prefer to do it. And because I like going back to the 0 term, I think it's a lot easier, then you don't have to worry about that whole n minus 1 thing. Okay, alright, so number 2, -4 to -8 to -16 to -32, times them by a positive 2 each time. So a sub n equals a sub n minus 1 times 2. Going backwards, -2 times 2 would give us -4, so a sub 0 equals -2. So in this case, it had a nice starting number, huh? Then our explicit, a sub n equals, we start at -2, we times by positive 2 to the nth. Okay, number 3. Now, whenever we see a negative to a positive to a negative to a positive, that should tell us right off the bat that this thing is multiplying by a negative number. So, -3 to get to positive 12, times by -4. 12 to -48, yep, times them by -4. So, a sub n equals a sub n minus 1 times a -4. And a sub 0, if we're going back, be -3 divided by -4, so positive 3/4, or 0.75 for those that are decimal lovers. Okay, so 3 divided by 4. So our explicit a sub n equals positive 3/4 times, and I'll put this in parentheses, negative 4 to the n power. And I put it in parentheses because that's just a good reminder of where it should be. Because sometimes in a calculator, if you don't put the negative in parentheses, it won't work appropriately. All right, number 4, 4 to 24 to 144. Now, this one may be more difficult for you to do. So if you're not sure, you can take this last number, divide it by 144, or 144 divided by 24. And that should give you the number that you're multiplying by. And if you do that, in this case, you'll find that you're multiplying by 6 each time. Okay, so and if we go back, 4 divided by 6, that can reduce to 2/3. So we start at 2/3. So explicit a sub n equals my start number, 2/3. What am I doing? Times them by 6 repeatedly, so 6 to the nth power. Then for recursive, a sub n equals a sub n minus 1 times 6. A sub 0 equals 2/3. All right, so just 2 more to go. So number 4, 4, 8, 16, 32, times them by 2 here. Going backwards, start at 2. So a sub n equals 2 times 2 to the nth. And a sub n equals a sub n minus 1 times 2. And a sub 0 also equals 2. That one was pretty simple, wasn't it? All right. 6. Now this one's different, right? Because now we're getting bigger and going smaller. Okay, so 48 to 24 to 12 to 6, looks like we're dividing by 2. Okay, so my recursive, that's fine to write a sub n equals a sub n minus 1 divided by 2. We know what that means. Okay, and so a sub 0, if we're going backwards, 48 doubled would be 96. And 96 divided by 2 gives us 48. Okay, but now the problem is with the explicit. With the explicit, I can't write a sub n equals 96 divided by 2 to the nth. Okay, we don't like to write that. Okay, instead, we like to say, well, what is dividing by 2 really? Well, if we were to change that to a multiplication, it's like 2 over 1, so we get the reciprocal, which is 1/2. So I could write times 1/2 here. Or I could leave that one divided by 2, but definitely on the explicit, I want to get in that habit of timesing by the fraction to the nth power, because that's how we deal with it in those cases. All right, so there we go. So an interesting thing, again, thinking about the difference between arithmetic and geometric, right? The recursive arithmetic a sub n equals a sub n minus 1 plus or minus some number, right? Then a sub 0 equals our start, our 0 term. Okay, recursive in geometric is almost the same, right? So if we times by the number, the constant ratio, or common ratio, and constant difference for arithmetic, the a sub 0 is still that 0 term, that beginning, that start. Okay, so really the only difference here is we're timesing for geometric, adding or subtracting for arithmetic. Okay, now for the explicit, that's where things do get a little different, don't they? Okay, for arithmetic, for now it's a sub n equals that start number, and then we are adding or subtracting our common difference, and then timesing by the variable. Okay, whereas with geometric, a sub n equals, again, that start number, but this time we're multiplying by the common ratio or constant ratio to the nth power. So, kind of interesting to see that there's a lot of similarity with the start number especially. So whether it's geometric or arithmetic, we're starting it the same way. But then we're adding or subtracting our growth times n. Here, multiplying our growth to the nth power. Okay? So, just kind of some interesting similarities and differences between the two. But there we go.